Okay, last thing I want to talk about a little bit is big data and marketing analytics. And here I'm going to go just a little bit deeper than I did in the book. One of the reasons the book is in beta is I don't know enough about this yet. So when it comes out with its official version, it will have a little more information, and I've got a little bit here better than what I have in the book. So let's talk about what it is, data, applications, some of the processes, and then issues. Mr. Cynic, did I mention INTPs look for the faults? So big data is a buzzword, really has no meaning. And it's used interchangeably with a lot of different stuff. In marketing, we use big data and marketing analytics kind of interchangeably, and when we do, we're talking about big data version of marketing analytics. I talked to a colleague who does have expertise in big data, and generally the accepted definition of big data is a database that's too big to be handled by a traditional statistical package. And so you need to use extraordinary means to get your arms around that data, and it provides opportunities for insight, and this is a wonderful statistic if you're into big numbers. Just to give you a sense as to what big data is all about. Exabyte, I think that's also a petabyte, is it's just a bazillion, yeah, how much?
I have a question.
Oh, you have a question. Come on, I'm trying to be impressive here. So what is your question? Yeah, I will try. I have that planned. I'm not going to do as good a job as you would like, because this is not an area that I'm strong in. Oh. So I will share with you the best of my knowledge, and if that's inadequate, I would love your feedback, and maybe I can do better next time. Boy, how's that for honesty? I had one of my mentors, when I was getting into teaching, he said that if ever somebody asks you a question and you don't know the answer, and you don't want to, look like you don't know the answer, say, "What do you think, class?" What do you think, class? So yeah, well, I'll touch on that, but I know I'm not going to be as good an answer as you want. So a petabyte is, just to give you an example, and this was a 2014 statistic, IBM was suggesting that we're generating about 2.5 exabytes a day. All of the knowledge generated by mankind up until the millennium was 12 petabytes, 12 exabytes. So we are each day generating a quarter of what the entire world's knowledge was up until. That's big data. That's bigger than any data set. And just when your thermostat start talking to your refrigerator and reporting through your phone, going through the satellite, that's all information. And they want to know your location data and who your friends are. Okay, so marketing analytics is kind of the version of big data. It's measuring, managing, analyzing. Now, marketing analytics is also everything that we do in database decision making and marketing. So market research is marketing analytics. And we're starting to tend to use the concept marketing analytics in the context of big data. Just to try, again, it's so new that we really don't have clear distinctions, definitions. But basically the difference between big data and regular data is that you've got the very large data sets. You're getting data from a variety of sources. The data is generated fast, usually in real time, and it's applied in real time. So this is the Amazon. It's analyzing millions of transactions. You make a transaction, and it tells you customers who looked at this also looked at this. That market basket analysis. Yes? So would an example of that be when you go to the grocery store, you scan your card and it gives you coupons? Yeah. See, and there's, what's the distinction? That would certainly be a source for big data, but you'd have a lot more than that. I combine that with your credit card data. I combine that with your phone records. I combine that with, I bought some demographics on you. I'd combine that with, I share that information with personal friends for marketing purposes. So anybody that you ever talk to. So that's what we call single point data, single source data, where that scanner tells you everything about that customer. That's one source of data for big data. But that was around way before big data. Back when I was a kid, they called it green stamps. It was the same concept, frequent purchase. So anyways, kinds of data that you have available, data that you own. Customer data, location. A lot of this is happening online, browsing. Data that you can acquire. You can buy syndicated data. You can buy individual data sets. You can buy census. And this is where I talk about free for a fee. Census data is free. Anybody has access to it. But there are companies that will take the census data and repackage it into a format that's more usable, and you will pay for that. So it's free information, but you're paying for convenience. And then cookie data, you can buy data from cookies on people's browsing behavior, people's history. And then you can also partner. Be one of your trusted friends, and every time somebody signs into the app, you get all of the information from that app. Those are all the kinds of sources of information that can come into a big data system. The typical applications, and this is about as good as I'm going to get for you, really three kinds of applications. There's optimization, where you try to do the best job of whatever it is. So in marketing, one of the optimization models would be to optimize the marketing spend. Are we spending the right amount on advertising, the right amount on promotion, the right amount on these kind of websites? What is the most effective, balancing all of these variables? Again, monitoring that in real time. Pricing information, this is the airlines publishing thousands of prices per minute. What is the best price? Always optimizing. And this dynamic pricing, we're getting more and more to dynamic pricing, not just in the airlines. But I've heard that many sporting events and entertainment venues are getting into dynamic pricing, where the prices for the tickets will vary in real time depending on what demand is. So again, this is a model. Another one is predictive modeling. This is probably where we've seen it most. Salesforce automation, marketing automation. The leader in that area is Marketo, which is a local firm. But very much business to business. They do lead scoring. They have the content funnel, which we'll talk about when we talk about content marketing. And the idea is that they analyze all of the data about customers and they make predictions about how ready they are to buy. And when the lead score gets to a certain point, then you can have one of your sales reps make a contact with the customer, but it just makes the time of the salespeople more efficient. So predicting what you might buy, predicting when they're ready to buy. Again, that Amazon thing is predictive modeling. If you bought Calvin and Hobbes, you'll probably buy another cartoon book. And then the last one, cluster analysis or micro-marketing. This really became hot in the I want to say 96 with John Edwards. Started really getting into the micro-marketing. And big data has gotten that onto where I can analyze massive amounts of information, massive amounts of customer files, and come up with maybe 3,000, 4,000, or 5,000 customer profiles and be able to generate specific offerings for each of those 5, 10, 15,000 customer profiles, almost to the point where we're getting down to a market segment of one. Because I can make a guesstimate based on your online behavior about who you are and craft automated individualized marketing offers for you based on your history, personalized with your name. So again, this segmentation, that's what's happening in politics right now, is with this micro-targeting, we can craft very specific messages knowing what people might be receptive to and make sure that you hear what we want you to hear, which is why now it's become standard practice for the opposition to infiltrate any political gathering with a microphone, so when they're speaking to the faithful, they can share what was said to the unfaithful. That's about as good as I'm going to get. I know. If you come up with a better answer, can you share it with me? Oh, you may. So the two basic ways that we do this, supervised learning versus unsupervised learning. Supervised learning is used for predictive modeling, and this is where we have some clusters or we have some patterns of data that we're looking for. We impose that structure on our database, and then we try to identify algorithms that would tell us what are the factors that would lead to the outcomes that we desire. And the outcome of that would be a predictive model, where when you look at new data, you would be able to say who's a customer for books, who's a customer for movies, who's a customer for food, based on that kind of data. And then the other approach is unsupervised learning. And this is rather than having some preordained or some patterns of behavior in mind, we're just trying to identify what the clusters are, what the patterns are. So rather than imposing a structure on the data, we just analyze the data looking for patterns in the data. Once we've identified those patterns, we see if there's any meaning to those patterns. And then when we get new data, we try to shape that new data so it comes into the new structures that we understand. Does that make any sense? Yes? No? Okay. And that's as good as I got so far. So let me tell you some of the caveats. Big data is a tool, and I see this a lot in marketing, is when the hot new toy comes out, everybody wants to use the hot new toy, but not everybody wants to use it. I just remember vividly, I was at a chief marketing officer's conference about 10 years ago, and this is when social was new. And the conversation went something like, I've just paid $500,000, I've got 50,000 likes on Facebook. Now what do I do? Because we all know you got to get likes on Facebook, right? But hadn't thought about how likes on Facebook would relate to what we're trying to accomplish. So we're kind of at that right now with businesses. Just because you have big data, unless you know what business problems you want to solve, what applications that you want to solve. You've heard the term in computers, GIGO, garbage in, garbage out. Computers make your decisions faster, they don't make them better. So, first question is, what is the problem that you're trying to solve? And I love this question. If you had unlimited data, if you had perfect information, what questions would you be asking? Okay. Once you've got that in mind, then let's take a look at, do we have the resources in place to do that? And there's two kinds of resources, and this was a good insight, is you need the technical resources. You need the people that are able to manipulate gigantic data sets and turn it into predictive models, cluster analysis, optimization. And then you have the people who have to implement those recommendations. And those people need to understand how those recommendations are going to make their lives better. If the computer tells you to do something, has that ever happened to you in your job? The computer told you to do something stupid? And what did you do? Well, if I was salaried, I ignored it. And if I was hourly, I did it. Because I'm not paid to think. I'm paid to do what I'm told to do. So yeah, those are the big ones. Is you need to first, what is the business purpose you're trying to achieve through marketing analytics, through big data? Second, what technical resources do you need to have that you don't already have? And then the third one, are the people who are going to be tasked to use the system able to understand the system and see the benefit that it will make in their lives? Otherwise, they're going to ignore it. I think that's it. How are we doing for time? We will pick this up next time and talk about something else.